Course agenda. Next, let's take a look at the course agenda. 1. Logic Design Fundamentals. In this chapter, we will cover basic logic gates, full adder example, simplifying logic functions with Boolean algebra, simplifying logic functions using Carnot maps, designing with NAND and NOR gates, hazards in combinational circuits, types of flip-flops, Mealy sequential circuit design, design of a Moore sequential circuit, state equivalence and optimization in sequential circuits, key timing considerations in sequential circuits, tri-state buffers and their role in digital circuits. 2. Introduction to Verilog. In this chapter, we will cover key concepts in digital design, hardware description languages, HDLs, levels of abstraction in HDL design, benefits of using HDL, roles in HDL-based digital system design, challenges in adopting HDL, key features of Verilog language, basics of Verilog module declaration, Verilog module hierarchy and instantiation, port connection syntax in Verilog, connecting ports in module instances, using procedural constructs in Verilog, synchronizing module behaviors, naming, rules, case sensitivity, and commenting in Verilog, simulating HDL designs, compilation, libraries, and elaboration. 3. Combinational logic design. In this chapter, we will cover basic gates using assign statements, majority logic and concatenation, shift operations, multiplexer 1, multiplexer 2, demultiplexer 1, demultiplexer 2, decoder 1, decoder 2, decoder 3, encoder 1, encoder 2, comparator 1, comparator 2. 4. Sequential logic design. In this chapter, we will cover metastability in bistable circuits, basic NOR latch operation, SR latch, D latch 1, D latch 2, D flip-flop 1, D flip-flop 2, D flip-flop 3, register 1, register 2, counter 1, counter 2, parallel to serial converter, pattern sequence detector. 5. Arithmetic logic design. In this chapter, we will cover arithmetic circuit design in Verilog, positional number representation, binary addition of unsigned numbers, signed numbers and arithmetic operations, adder 1, adder 2, adder 3, adder 4, adder 5, subtractor 1, subtractor 2, multiplier 1, multiplier 2, multiplier 3, divider 1, divider 2, fixed point numbers, floating point numbers, binary coded decimal representation. 6. FSM logic design. In this chapter, we will cover finite state machines, FSM, overview, state machine design, components of FSM logic synthesis, FSM design process, FSM coding, modeling the states, FSM coding, state memory block, FSM coding, next state logic block, FSM coding, output logic block, FSM example, serial bit sequence detector 1, FSM example, serial bit sequence detector 2, FSM example, vending machine controller 1, FSM example, vending machine controller 2, FSM example, 2-bit binary up/down, counter 1, FSM example, 2-bit binary up/down counter 2. 7. Synchronous logic design. In this chapter, we will cover synchronous sequential machines, synthesis procedure, equivalent states, Moore machines overview, Moore machines example 1, Moore machines example 2, Moore machines example 3, Moore machines example 4, Moore machines example 5, Moore machines example 6, Mealy machines overview, Mealy machines example 1, Mealy machines example 2, Mealy machines example 3, Mealy machines example 4, Mealy machines example 5, synchronous registers overview, synchronous registers. Example 1, synchronous registers example 2, synchronous registers example 3, synchronous registers example 4, synchronous counters overview, synchronous counters example 1, synchronous counters example 2, synchronous counters example 3. 8. Asynchronous logic design. In this chapter, we will cover asynchronous sequential machines, synthesis of asynchronous machines, understanding hazards and circuits, oscillations in asynchronous machines, races in sequential machines, asynchronous design example 1 part 1, asynchronous design example 1 part 2, asynchronous design example 1 part 3, asynchronous design example 2 part 1, asynchronous design example 2 part 2, asynchronous design example 3 part 1, asynchronous design example 3 part 2, asynchronous design example. For part 1, asynchronous design example. For part 2. 9. Digital system design. In this chapter, we will cover bus structure 1, bus structure 2, bus structure 3, simple processor 1, simple processor 2, bit counter 1, bit counter 2, bit counter 3, bit counter 4, shift and add multiplier 1, shift and add multiplier 2, shift and add multiplier 3, shift and add multiplier 4, enhanced divider 1, enhanced divider 2, enhanced divider 3, enhanced divider 4.